Hello there, students from Big High School. This is teacher Krishna Ochoa, and welcome to our physics class for week number 12 for 10th high school. So this week we're going to study the topics 2.03 and 2.04. Right before we start, we have to go pretty quick over some general instructions. Log into Agilex, enter the Google Classroom, download your Word document and save it in your physics folder. And lastly, name your document as it is specified at the bottom. Use week number 12 in your code, name, grade, and section. As we move, remember that it is very important for you to take notes over the most important things that you can identify from the video. It is also important to remember that we have to start with our end in mind, and for our class today is the following. The students will be able to clearly describe the relationship between data stated in a graphic for application through a conducted investigation related to motion. That is the first thing you need to write in your document, so take it into account. So we're going to go over some motion graphs, topic 2.03. We're going to analyze some graphics related to position and time, and some others related to speed and time. So first of all, here you can notice that on the y-axis we have our position in meters, and in our x-axis we have our time in seconds. So how can we explain or describe this graphic? Let me show you one example. Here you have it. The object is moving from 0 meters to 25 meters at a constant speed of 5 meters per second, from 0 seconds to 5 seconds. Notice the object is covering equal distances in equal times. So just like you can notice here on the graphic, there are not many curves, or we don't have any abrupt changes in there, but we just have a constant linear change that is constantly getting higher from the bottom to the top, from left to right. That is why we say that it is moving at a constant speed. Here we have another example. The difference between this one and the last one is that this one is the opposite. The object is moving from 25 meters to 0 meters at a constant speed of 5 meters per second, from 0 seconds to 5 seconds. Notice the object is covering equal distances in equal times. Pretty similar to what we just talked about in the last graphic. Now here we have a graphic that is a little bit different. So you can notice that it has a mark in the 10 meters position, and it continues there even though the time still increases. So here is the interpretation. The object is at rest at a 10-meter position for 5 seconds. Notice as time moves on, the object covers no additional distance with respect to the origin. We call this rest. So basically, when an object is not moving from its position, it is in rest. Right, so now there is a tool that is called a ticker tape motion, and it helps us to measure the intervals in between time and displacement of an object in movement. So here we have a summary on the most important aspects that you need to take into account when interpreting the information from the ticker tape motion. So basically what it does is that while an object is moving, it is going to start adding dots to a specific piece of tape, which at the end can be interpreted in a certain way. So here is how you're going to interpret the dots in the tape. So if they have equally spaced dots, it means that the object is moving at a constant speed. Next one, more spaces between the equally spaced dots, object moving at a faster constant speed. Spacing between consecutive dots increasing, object is speeding up. Spacing between consecutive dots decreasing, object is slowing down. And lastly, a bunch of dots bundled in one location, object is at rest. So this is better exemplified with a real example. So let's check the one that we have here. So this is the tape that you can find from the tool. So as you can notice, we have two different samples, but they have something in common, that the distance in between dots are pretty much the same. So when we find dots like this from our tool, it means that the object is moving at a constant speed because of the spacing in between them, right? Here we have another example. So at first you can notice that all the dots are together, but later on they are way more separated. So it means that the speed is increasing in the sample. But if we notice the last piece of tape that we have at the bottom, basically what happens is that the speed is decreasing because the spacing in between the dots is getting smaller and smaller. And here we have our last example. So when we find a lot of dots bundled in the same spot, it means that the object is in rest and it is not moving anymore. So it's time for an exercise. So please complete 2 of the 4 questions in page number 3 for topic 2.03. Add it to your Word document. So go ahead, you can stop the video, and once you are done, you can come back to the presentation. Now we have to take a look at the following topic, which is scalars and vectors. So scalars, it is data that can be described by its magnitude. Here we have some examples. In distance, we have 5 meters, time, 10 hours, and in mass, 6 kilograms. So what is exactly the scalars that we can find in here? Basically, they are meters, hours, and kilograms, because that is a magnitude that we're measuring. On the other hand, we have vectors. So they require magnitude and direction. Here is the difference between both. In vectors, you need magnitude and a direction. For example, we have 5 meters north. So what is the difference in between distance and displacement from the previous example we have? That here we have direction. Another one, 45 miles per hour west. That is velocity. One more time, we have magnitude and direction. Right, so it's time for a very brief exercise about vectors. So you have to complete all the exercises in page 2 of topic 2.04. One more time, you can stop the video. Once you are done, you can come back here. So here we have a very nice and explanatory image about how vectors work. When are they going to be positive and when are they negative? So basically, if the vector is heading north and east, the values will be positive. But if they are heading south or west, they will be negative. All right? This can remind us of other graphics that we do in math class. Because if the vectors that we're analyzing are going up or right, then they are positive, and if they are going down or left, they are negative. And now here is an example of how we can combine 2 vectors. Vector number 1, 3 centimeters east, and vector 2, 4 centimeters west. Remember, east will be positive and west will be negative. So basically, our final result will be -1 centimeters. And of course, it will be heading west. Right? But what happens if the vectors we are analyzing are not going in the same axis, just like in the previous example? Here we have vector 1, 3 centimeters east, and vector number 2, 4 centimeters north. One is going right and the other one is going up. So how can we find the result? So we have to use some trigonometrical principles in order to find out about it. And just like it is specified in the image, and we have to find the hypotenuse of a triangle in order to find out about the result. So, in order to complete this, I need you to read and analyze compute the angle using trigonometry. I'm sorry. In case number 3. In page number 3 of topic 2.04 to find the answer of the previous problem. Then please complete 2 questions from this page as well in order to exercise a little bit more. So once you're done, go back to the video and you will continue. Alright, lastly we have our evaluation. So reading summarize topics 2.03 and 2.04. Notice that most of the information that you will find in those topics is here in the presentation, but it's always good for you to reread the presentation in order to clarify some questions that you might have, and in order to complement the summary that you already have. Then complete the quizzes for topics 2.03 and 2.04. Remember that you need to study a little bit before you take the tests, because you are not allowed to use your summaries, videos, or Google, because keep in mind that these quizzes are going to help us to measure how much you have learned during the lesson. Observations: each evaluation is 5 points for a total of 10 points. And I wish you the best of luck in this evaluation. That is it for this week's class. I hope that you have understood it totally. So it's been great working with you this week. I hope to see you soon. Goodbye. Take care.